Welcome to this video on designing experiments. By the end of this video, you should be able to describe the placebo effect and the purpose of blinding in an experiment. You should also be able to describe how to randomly assign treatments in an experiment using slips of paper, technology, or a table of random digits. And finally, you should be able to explain the purpose of comparison, random assignment, control, and replication in an experiment. Before we start this notes video, make sure you go and watch the video that's referenced in the beginning here. It is linked on our Canvas page for today. It will give you the whole context that the rest of this is built around. So for our first question, why do you think the people in the video got stronger? Obviously it wasn't from what they drank, so really it's because they thought they should be stronger, so maybe they tried hard. So maybe they thought they should be stronger after drinking whiffed. If you don't know what that is, you didn't watch the video, so make sure you go back and watch it. So maybe they tried harder. So they wanted to be like the other people in the video. So similar to the video, I want you to use a beverage to test the effect of caffeine can have on heart rate. Here's my initial plan. I'm going to measure initial pulse rate. I'm going to give each student some caffeine. It could be Coca-Cola, it could be caffeine water drops, whatever. Wait a specified time, measure the final pulse rate, and then compare the final and initial rates. Do you think there's any problems with this plan? What other variables could be a source of variability in the pulse rates? Go ahead and pause the video and come up with a couple ideas here, and then come back and see how you did. All right, here's a couple of the ideas that we came up with in class. So some of the problems, really, there's nothing to compare it to. You're talking about one person here, their initial pulse rate and their pulse rate after. So there's not a whole lot to compare it to. One thing that was a good idea was sugar may actually increase their pulse rate because sugar gives energy. So maybe that would increase their pulse rate. And another idea that we had was people could know they're getting the caffeine and start to feel the effects even though they didn't actually have the caffeine. We're going to talk a little bit more about that in a minute. Okay, so let's kind of talk about these. So right up here in our initial scenario in the video, why do we think they got stronger? They thought they should, so they maybe tried harder. That's something called the placebo effect. So placebo effect is really when a fake treatment works. You'll hear about that in drug trials where somebody maybe gets a sugar pill instead of the actual medication. And people initially will have a response and respond the way they think the medicine should make them feel or act or do or whatever. But eventually it catches back up to them and the effect isn't long lasting. And that's part of so that's your placebo effect. It's a fake response. So that's what is right here. So we're going to list a proposed solution to each of these. So people could know they're getting caffeine and feel the effects. That's your placebo effect right there. It's not real. But one way you can help this from happening is you can do something called blinding. So when you do have blinding in a study, there's single blind where the participant does not know what treatment they're getting. And then there's double blinding where the participant and the person giving them the treatment don't know which treatment they're getting. Because you can have influence from the person giving the treatment too if they actually know which treatment they're giving, and they could give away something and cause a placebo effect to occur. So if you're trying to avoid your placebo effect, blinding is the way you want to go. Sugar may increase the pulse rate. One thing that we can do here is we just need to try and control for other variables. So maybe give them sugar ahead of time and then measure their pulse, then give them caffeine and measure their pulse again. Something to control for the sugar, okay? And then the last one up here is really the first one. We don't have anything to control it to, so we really need, compare it to, we need a control group. So your control group kind of gives you a baseline for measurement. And these two can kind of go together, so we're trying to control for other variables. Maybe we use caffeine-free Coke, so sugar isn't an issue, or we just got to have a way to control, or we have note that one group doesn't drink caffeine, one group does drink caffeine. I don't know. There's a bunch of different ways, and each situation is different. So we're going to design an experiment here. We could do this in a paragraph form or in our scaffolding form. I think I'm going to use the scaffolding form because I think it gets our point across. So we're going to do something and completely randomize our experiment here. So if we want to, let's say we're going to have 100 students. So you know I always like to start with my drawing of my people, and they're always happy. And so I'm going to have 100 students to start with. Okay, I need to put them into group. So we have to have random assignment. You can't just decide. So we're going to randomly assign. And in there, we're going to end up with 2 groups. So we're going to have 50 and 50 people. Now, what are going to be the treatments here? So I want to see the effect of caffeine. So I'm going to have a regular Coke. That's going to be your treatment 1. And I'm going to have some caffeine-free Coke. And that will be my treatment 2. So once everybody's had their Coke, you're going to have to measure their heart rates again, and you're going to have to compare at the end. All right, so what's real important when we're drawing these designs, you want to tell me what you're starting with. You've got to tell me that you have randomly assigned, and you want to split these groups to be approximately equal as much as you can. And name your 2 treatments, and you always compare at the end. So this one is called a completely randomized design. This is your ideal. Okay, so completely randomized design. So the reason this is ideal is some of these issues that we were talking about up here is we now have a control group. They're the caffeine-free Coke, so we can kind of see how the caffeine people compare to the non-caffeine people. They both would have sugar in it, so that would be less of an issue because they both are getting sugar. So even if both their heart rates go up, if the one group goes up more, maybe it really is the caffeine. You could put blinding in there to avoid your placebo effect. And these students might not actually be randomly picked. They may be volunteers, 100 volunteers. So you already know volunteer is a bias. However, if we can randomly assign out of this, that helps reduce some of that bias also. So that's why this random assignment here is very, very important. All right. So let's do some summary. We got a lot of stuff that went on, and it doesn't look like a lot, but there's a lot of ideas here. So let's unpack that. All right, I have 2 major sections, and you can see this right one's a little bit bigger, so allow for some space there. So our first big ideas that we want to be sure we take out of this is we've got our control group. Remember, your control group is used to provide a baseline data for comparison. So in our experiment that we just did, our control group received no caffeine. They had caffeine-free Coke, but you don't want them just to have nothing necessarily. You just want them, in this case, we wanted them to have something so they seemed part of the experiment, and that could help cover with your other variables such as the sugar and do some controlling there. Blinding. remember, you have the two kinds of blinding. You have single blind when the subjects do not know if they're receiving the treatment, and you have the double blind, which is when the subjects and the experimenters are unaware of what treatment is assigned. This is very common in medical situations where they're like a drug trial. The people giving the drug can give subtle hints like, are you feeling better? Or they could rate patients differently if they think the patient is receiving the trial drug. And so they try to take that away from them. And they do it unintentionally. They're trying to help the manufacturers with the positivity in the drug or the negative effects in the drug, but they really want to know what's truly happening and not a fake response. So that's why double blinds are used, especially in medical trials. And then we have our placebo effect. That's when a fake treatment works. It happens all the time, and so it's good to be aware of it. And now, here is our key principles. These are pretty important. The key principles of experiments. You have to have comparison. So remember when we did our scaffold design, at the end we always make a comparison. So you're going to need 2 or more treatments. If you're just having people drinking some Coke and then measuring their pulse rate, what are you comparing to? Nothing. So that's why that design doesn't work. You need to have 2 or more treatments. Then we have our random assignment. We need to use a chance process to assign treatment to our experimental units. They have to be randomly placed into their treatment. I can't make the decision. You're going to get this and you're going to get that. That has bias. So we have to use some sort of random assignment. Then we have our control group, and that keeps all the other variables besides the treatment constant. And so the group drinking the caffeine-free Coke, they were getting sugar in their Cokes, and that was one of the variables we were kind of worried about. And so that kind of helps. They got some sugar just like the other group, so the difference hopefully is truthfully whether it's the caffeine or not. All right. And then replication. You need to use enough experimental units to distinguish differences. So you need to have a larger sample size. I've read research studies where they might only have 1 or 2 subjects. Well, that doesn't really mean anything if you only got a response from 1 or 2 people. That might be the start of a much bigger research project, but it's not groundbreaking or earth-shattering if you've only got a couple of experimental units. This needs to be working over many experimental units over time so you can kind of see the differences. All right, what I'd like you to do now is pause the video, answer the check your understanding, and then come back and we'll go through it. Do try to answer these on your own. That's how you know if you're starting to understand the material or not. All right, so our scenario in the Check Your Understanding. Many utility companies have introduced programs to encourage energy conservation among their customers. So they have a couple different approaches here. They have small digital displays that they place in the households that shows the current electricity use. Can you imagine if you were looking at that? Like, it would become such a game for me. I'd start being competitive. I'd probably freeze to death in the winter. Another idea is to give customers a chart with information about monitoring their electricity use. It's like, this is things you can do to monitor your electricity use. And the third one, just those 2 approaches. Which one will work just as well? Nothing, the approach, or this digital display. So explain why it is important to have a control group that didn't get the displays or the chart. So the reason this is important is it allows us to show how much more electricity customers normally use, and it helps provide a baseline data. So it just gives us an idea of where were they at, where are normal people at compared to the people who got this display or this chart. Okay, so that's where our control group comes in. So this is the paragraph version of our experimental design. All right, so we're doing for 60 households, so we would label all our households. Remember, you got to label 1 to 60. Use a random number generator. The first 20 selected will get the display, the second 20 will get the chart, and the remaining will be the control group. Okay, that's one way to write that up, because you remember you want to make approximately equivalent groups. So what is the purpose of randomly assigning treatments in this context? So when you randomly assign, you are creating roughly equivalent groups, and you're balancing out the other variables. We're kind of assuming that all of these people kind of have the same characteristics. Okay, and so when we put them in 3 different groups, we're assuming the people are somewhat alike. You know, they're homeowners, or they're adults, or they're alike in some way, shape, or form. Okay, and so now our design. So we started with a simple random sample of 60 houses. Usually you don't even get that as much in the beginning. You get volunteers, but we'll say it's a simple random sample of 60 houses. We're going to randomly assign. We set up here what we're going to do. We're going to label, we're going to select. We said how we're going to do it. So we got 20 going into each group. So our first group gets the treatment of the display. The second group got the treatment of the chart, and the third group was our control group. And at the end of the period of time, then you're going to compare their electricity uses. Any differences we see at this point, because we've done all this random assignment, we're going to assume was caused by the different treatments. Okay? So hopefully that was helpful. Let me know if you have any questions.